Hello everyone. So today we will cover the topic of what is a SCADA, and I will talk about a brief idea about SCADA. SCADA is a huge subject. If we devoted 10 days to it, it would not be possible to cover SCADA totally. So what we'll do is today we will cover the basic terminology and selection of what a SCADA is, right? And then in the next time in a different training session we'll go into actual function by function of a SCADA. Today it will be an overview of SCADA. Okay, so does any one of you know what is a SCADA? What is the full form of a SCADA? Not you, anybody else?
Yes, sir. Supervisory control data and acquisition.
Supervisory. So these are the functionality. This is what SCADA is: supervisory, control,
And data acquisition.
and data acquisition. If you look at it, SCADA is a software, essentially a software running on a PC, running on any Windows or non-Windows environment, uh, which can do these functionality. And there is some amount of automation, some amount of logic also that you can do it. But then that is SCADA is not made for that. It can do it, but it is not made for it. SCADA is mostly made for supervisory action and data logging. If you want to do actual, control system, you need to have a PLC or a control device to do your controlling. But SCADA can also do a control for you. Can have a PID loop in SCADA, so that is also possible. But that is not its primary function. So primary function of SCADA, it's a software which will supervise. What will it supervise? Any industrial process. This is not a software which will be used on for home purposes. It can be used on a home purpose, but it is essentially designed for a industrial process and any kind of industrial process. By industrial process, you could be have a edible oil refinery. Now that could be using a SCADA. You could have a machine shop that could be using a SCADA. You could have a factory where you are doing energy monitoring. So there you could be using a SCADA. So these are the various functionalities of usage of SCADA. And uh, the difference between a PLC and SCADA is SCADA does the supervisory. It sits on the top. On the bottom, there are the actual equipment that you have to monitor. For example, energy meter. For example, a vacuum pump. For example, a pneumatic valve. These are the actual equipment in the field. Now, on the top of it, all of these will talk to a PLC or a programmable or a non-programmable device. So you have two type of control devices. One is a programmable device which is flexible. You can change the program, or you have dedicated controllers. For example, PID controller is a dedicated device. डेल्टा का वो जो कंपोनेंट आता है फॉर कंट्रोलिंग द solar inverter, DGPV sync of Delta. What is it called? Del Remo. So Del Remo is a dedicated controller. It cannot do your industry job. So these are the two different kind of controllers that are available in the market, and we are concentrating primarily on programmable logic controller, which can be reprogrammed. It has a EEPROM, so it can be erasable electronic. So how do we specify a SCADA? Specification of SCADA will come by the definition of number of tags. How many tags, how many points are there in a SCADA? So normally you have SCADA which is 50 point, 50 tag, then you have 75, then you have maybe 100, and different companies will market it differently. And there are companies which will say, okay, we will give 1000 tags and nothing less than 1000 tags. So then you have unlimited tags, which means you can endlessly do it. So that is one way of defining by number of tags. Second way is what communication protocols does it support. Normal is Modbus, but you can have Ethernet, Modbus TCP/IP. Then you can have Profinet. You can have multiple protocols. So that is also a way how you define a SCADA, how you specify a SCADA. Then you could have SCADA definition by some special features. For example, does it have a recipe management function? So what is a recipe management function is when recipe, as you know, is like when you are cooking. So you know you have to put in 1 spoon of salt, then 1 onion, 2 tomatoes, and so much of vegetable. So there is a defined recipe. So what can be done if you have a recipe management in the SCADA, you can click on the recipe of, let's say, aloo matar, and you click on it, and the values of aloo matar, the recipe proportion, can be downloaded into the device like PLC automatically from SCADA. So nobody has to input data. By press of one button, a predefined data will be downloaded into the PLC and it will be produced. For the prime example of this is, if you remember, Asian Paint used to run an advertisement which used to say, where the lady is selecting various shades of pink color, and then she says, "Oh, this is ye mera wala pink hai." Now, how does Asian Paint make the same pink color every single time? So they have a recipe management software in their SCADA. So recipe management, they will click pink color number 1101, and once they click on that, the data, how much of valve has to open, how much of steam has to open, how much of temperature will be done, how much of vacuum pump will be done, all of them will come predetermined. So nobody has to remember, nobody has to make notes. So this is called as a recipe management. So you can even define SCADA by recipe management or special feature. You could have some SCADAs don't have a report functionality. It should have a report functionality, but the way commercially it is sold, some SCADAs don't have a reporting facility. So you may have to buy a report management separately, or it could be inbuilt, or you could have some basic report management in it. So that is another way how you can define SCADA. Some SCADAs have and some don't have the calendar function. For example, you want 26 January, 15 August, you don't want your processes to run. So if you program in your calendar that 15th August and 26th January plant will not run, then nothing, none of the PLCs, none of the devices get will switched off until unless somebody bypasses them if it is so programmed, right? So this is another way. These are how we specify SCADA. This is the basic fundamental ways how you describe a SCADA. If you go out in the market, all you need to मेरे को 1000 type का SCADA चाहिए. That is how simple it is. But which presupposes that protocol, basic protocols are there. Then what are the key terminology that you need to know to configure a SCADA? Is anybody here who's not clear about AI, AO, DI, DO? You're not aware. Okay, I think except Yatandra, nobody else knows. So, digital input, digital output, analog input, analog output. Digital input is when you switch on a fan. So, it is either on or off. But when you change the fan speed, that is analog. So, you can increase the speed or you can decrease the speed, right? And that is a digital input, output and an analog output. A regulator is a analog output. A switch for fan is a digital output, on or off, 0 or 1, binary state, right? So this is then you have analog output. For example, if you wanted in Asian Paints, they want a valve for that color making, they want it to open to 65%. How do you achieve that 65%? So you give an analog output command. So analog output command could be 4 to 20 milliampere, 0 to 20 milliampere, 0 to 10 volts, minus 5 to plus 5, minus 10 to plus 10, and it is continuously changing, right? So anything, any value that can change. For example, if I'm heating water, so the temperature from if I take ice and then to boil it, the temperature will, if I put a thermometer, the temperature will change 0 to 100 degrees. and the input on my PLC will vary from 4 to 20 milliampere. If it is or 0 to 10 volt. Inside the PLC, it will vary from 0 to 32,000 digital value. So it will in proportion scale to 0 to 100, scale to 0 to 32,000, scale to 0 to 100. And in SCADA, also you can actually program it that way. It will show you temperature 0 to 100. Right? So this is analog output. This is the usage of analog output. Then analog input. Now if you want to see the temperature as I just explained. So this is an analog example of an analog. And digital output and analog output I have already explained. Right? So these things, if you do not understand, then you will never be able to understand SCADA properly. This is a fundamental, you need to understand when you are buying a SCADA, how many digital inputs, digital outputs, analog inputs, analog outputs are you needing to control. Unless you know that, you will not be able to achieve that. So this is one point. Then where do all of these DIDO, AIO sit? They sit in a PLC, let's say. But PLC is only one type of device. As I just explained, there could be some dedicated controllers, some PID controllers, some Bell Remos. So they are dedicated controllers. So they, in totality, we call all of these things as devices. Devices will have the input output. So device can be of multiple types. So you need to understand the terminology. When we talk next time, if I say, okay, we have a device, so you should understand what a device means, right? So you will have device, and each device, if you have 100 devices, how do you identify them? So you have a device ID for each of those devices. Once you have the device ID, you can configure it, you can address it, you can send a command to that particular device, right? But the beauty of SCADA is, in SCADA you don't have to, once you have configured it, you don't have to actually every time write as device. You can say my paint mixing machine PLC. So you can easily, it is easier to understand. In SCADA you don't have to remember every address, every digital address of that, what is the memory bit of that, so that becomes too complicated. So then after device ID, a device will have two more things. It will have a communication port and it will have a power supply. So DIDO, AIO, then it will have a communication port and it will have a power supply. If it has all of these, then it is a device. And communication port can be of multiple types, and I'll come to that a little later. If in paint shop there are 20 machines and each has an individual PLC, but paint shop is one, so paint shop will be called as a resource. So if we have a resource of a paint shop, then you can change the properties of all of them in one go if you change the properties of resource. That is why it is necessary to differentiate between what is a device and what is a resource. So it is easier for us to talk about and to configure in SCADA. So you'll have a resource which could have a single PLC, which could have multiple PLCs, and each of those PLCs could have multiple equipment connected to it or a single equipment connected to it. If you have any question anywhere, if you do not understand anything, please feel free to talk. Now, if we come to the SCADA software itself, so what does the software do? If it is, let's suppose, running on a laptop, you will see a screen which will have a diagram of your process. If you have a paint shop, and if your paint shop has a particular machine, you can actually take a photograph of it and paste it in SCADA. Or you have an object library from where you can download push buttons, valves, sheds, multiple it's a library, and you can create your own library also. You can draw an object and give it properties. It'll, and what those properties are, we are discussing now. So each object could have multiple properties. So if I make a valve, a paint flow valve, which is regulating the flow of the valve. Now I could make this object in my SCADA. I'll draw it. It's called as a mimic. It mimics, it copies, it looks like what the actual thing is. It is not just a rectangle. You can actually draw it, freestyle drawing, and make it look like the real object. So the object will have properties like color. The object would have certain size. Then you could also have color animation, which means as the temperature of the ice goes from 0 to 100 degrees, the color will change proportionally from blue to red. So as the temperature goes up to 100, it will keep on turning red. At 50 degrees, it will be 50% between red and blue, right? So that is color animation. Then you will have animation of size. You could have, as the valve opens, maybe my size of the valve keeps on increasing if that is what I want. So that is size animation. If there is a fan like this, you can make it rotate. The moment you switch on the switch in your software, SCADA software, you will see the object that you have drawn as fan will keep on start rotating. You can assign that property to it. You can configure that. If you are 50 objects on your SCADA screen, it becomes very cluttered and you're not able to visualize it properly. The whole idea of SCADA is to visualize the process easily on a laptop. But then plant is 400 feet by 200 feet wide. How can it fit into a laptop screen? So you have to draw it smaller, but then visibility issue is there. So whatever you are not using currently, you can just remove its visibility. So the object will be visible only when you want it to be visible. This is another animation or configuration aspect that you can do. Then you can create buttons. Just we said that by switching on this button, the fan switches on. You can actually configure on SCADA a button. When you click on that button, it gets transmitted to the device, and on the device a digital output will be switched on. That digital output will drive, let's say, a contactor or a relay, which will switch on the fan. So by clicking a mouse on a button, you can switch on or switch off any of the digital devices like a fan or an on-off valve, anything like that. You can have movement. Object can move from here to here depending on the value of input. So that is another animation. It can actually become like a movie. You can actually make things move from here to here. If, for example, your forklift is giving an output and you are able to map that onto SCADA, so as the forklift moves on your SCADA, you can see where it is currently. Or if you have a trolley, that trolley is giving you input, then you can see where your trolley is currently in the process. So this is what animation you can build to it. You can have a slider. For example, if you want to change the temperature setting of that paint we were talking about. So you want to touch, so you can move the slider up, so your temperature goes from, let's say, 100 degrees centigrade to 130 degrees centigrade. So you can do that. Or you can have set point. What does set point do? Set point, you can type into it 130 degrees, enter, and then the valve moves directly to 130 degrees. So that is another functionality of SCADA, set point. You can have password protected set point. You don't want the operator to change. You want only the manager to change. So you can protect your set point or slider or any other, even the button, any of the outputs or any visibility you can change as per the password level. You can have multiple levels of password. Operator has one password, manager has one password, then super manager has another password, and then the programmer may have another password. So multiple people can be given multiple roles. So you have to configure roles of different people and then assign them uh, the passwords accordingly. Then we were coming back to devices. So your devices will have multiple or a single communication port. So it will have at least a RS-232 communication port. It may have a RS-485 communication port. These are various communication ports over which you will communicate with your SCADA and the device. Or you will have an Ethernet port. Most of your laptops have an Ethernet port. You have a USB port. USB port is not industrially used too much. Of course, now in the newer devices it is available, but in older devices, RS-485 and Ethernet were the most popular ports that are available. But ports can also be in multiple formats. For example, you can have a port on an RJ connector. So you have a RS4, RS485 communication port on an RJ connector. You can have a RS485 communication port on a D connector, or you can have a RS485 communication port on terminals. Or there could be multiple different formats. You could have it on a BNC connector. So there are multiple formats in for Ethernet. Also, you can have an Ethernet on RJ connector, or you can have it on a terminal, or you can have it on a D connector also. It is just how you connect wires. It has nothing to do with technology. Then some of the most common protocols, I'll just repeat, that are used in SCADA is Modbus. Modbus can be serial. So protocols are uh, classified in two different categories. One is a serial and one is peer-to-peer. Peer-to-peer example is like your Ethernet, and RS-485 is a serial communication protocol. So what is a protocol? Anybody has idea what is a protocol?
So, some rules and regulations to follow the.
Yes, but in simple language, how am I talking to you in English? Or I could talk to you in Hindi. Or I am a Kashmiri, I can talk to you in Kashmiri. Or I know Punjabi, I can talk to you in Punjabi. So these are, we can say these are four protocols. These are four different languages by which you communicate between SCADA or PLC or any other device. It is as simple. And obviously there are some rules that are defining those protocols. So that it is as simple as just a language. So you most of the times we are using Modbus RTU serial, RS485, 232, Profibus, CAN bus, Modbus TCP/IP, Ethernet, Profinet, Profibus. These are all names of different protocols, different languages which are used to communicate. And the reason we have so many different is because the applications are different. If you want very high speed, you don't use a serial communication, because serial communication is 19.2 kbps most of the times. There are some devices which allow much higher than that, but it is still limited. Whereas in a peer-to-peer Ethernet, what is the speed? 1000 Mbps. Today, Ethernet is available at 1000 Mbps, so the speed can go up. The distance is, but while you have 1000 Mbps, but Ethernet cannot go more than how many meters? 80 or 90 meters. So that is another limitation. Though it has a high speed, then you need to go into a different media. So you can have Ethernet over fiber optic. So speed is also high and distance is also covered. So these are various medias and protocols which we play around with to achieve a goal. But if we are giving a SCADA to somebody, we have to ask him protocols are your devices communicating now, and as per his devices, we will select our protocol, our SCADA protocol. So we may have to buy a protocol, communication protocol separately, right? For example, in substation, you use a IEC 680 dash 5 dash 104. This is the protocol that you use in a substation. So if you don't have a protocol in your SCADA, then you have to buy it, attach it, or you need a protocol converter, which will convert Modbus to IEC 60870-5-104 protocol. So you have protocol converter, and it can be two-way. From while transmitting, you are converting Modbus to IC protocol, and then wherever it is being delivered, you are converting IC 104 to back to Modbus. That depends on the configuration of your application. Then in each device, if you have a multifunction meter, that is the easiest to understand. So a multifunction meter, you need to pick up what data? Hanji, what data do you need to pick up?
Voltage, current.
Voltage, current, kilowatt, kVA, power factor,
Reactive power.
frequency. But in the device, where is this data? How do you know? So you need to have the memory map of those devices. Normally it is available on the net. If it is not available, then you have to go and ask the client, please give me the memory map. So memory map is nothing. It is a map like a Google map which tells you, oh, you want voltage? It is on address number so and so. It will give you the address. So if you have the device ID and you have the address from SCADA, you can straight away zoom to that and pick up that data and attach it to some object in the SCADA. So you have an object in the SCADA, you will attach it to a device, and that device will be attached to a memory in once you know the memory map, right? So similarly for voltage, current, kVA, and some of the in memory map there will be two type of memories. One read only, one read write. So where it is read only, for example, voltage in a multifunction meter, you don't want to write onto that. You only want to read. But if you have a PLC where you are measuring voltage and you want to change the servo setting, so you'll have an output where you'll be able to change the servo setting and thereby the voltage will change. So you need to write into the PLC. So you will have a write functionality. So you have a read only or read write facility. So this is also what you need, a memory map of the devices so that you know how to address, how to reach there. Okay. And then what are the functions that are available in SCADA? The functionality in SCADA, once you have the data voltage, once you have the analog input, it is available to you in SCADA. Shh, please. So once you have all of that, what do you do with it? You remember in a device, the valve will give in output in the form of 4 to 20 milliampere. In the PLC, it will be received as 4 to 20 milliampere. Inside the PLC, in their PLC memory, it will be 0 to 32,000. And when you read it in SCADA, you can read it raw as 0 to 32,000, or you can scale it and then read it 0 to 100%, let's say. So you have the function, all the arithmetic functions, divide, multiply, scaling, all of those functionality are available. You will have even the logarithmic functionalities available. You can add value of 2 tags to derive a third tag. That is also possible. Then you have set point facilities. Then it is up to you. These are all the functionalities are available to you. You also have gates. OR gate, AND gate, NOR gate, NAND gate. You must have read about it in college. So all of that functionality is also available to, so you can OR two inputs, two digital input. If this or this is high, then do so and so function. It triggers something else. Or you could have a NOR function, or you could have an AND function. So all of that functionality, then it is up to your skill as a programmer, how you achieve the application using all of these functionalities that are available. Then you also have logical expressions like if value of set point is greater than so and so, then do so and so functionality. So if less than equal to, less than equal to, greater than equal to, all of these logical expressions are available to you. So I think this is more or less the conclusion of today's briefing of what a SCADA is. But there are two things that you need to know. What is the most difficult on all of this? It is not understanding the SCADA, understanding the PLC. It is the application. Until unless you understand the application, user application totally correctly, you will not be able to select the right SCADA. You will not be able to select the right device. You will not be able to select what protocol is suitable. If your data connection is to happen every let's say millisecond, then your serial communication will not be right. So you need to understand the application in depth. Unless you do that, you cannot configure a SCADA correctly. And then there are multiple things that are to select when you are talking to a client. You need to ask him the details. What is the protocol? How many devices are there? There's a limitation. For example, a serial device you can read only 32 devices on a serial protocol. So if he has RS485 and he has 64 devices, you cannot read it singly. So then you need to have two RS485 buses, bus 1, bus 2. So that is why you need to understand the client's application, layout, cabling, and you need to question him properly. And once you have all of this data, then you can say, yes, I can configure this SCADA. Okay. So part 2 of this training will be done later now. Right? Okay. Thank you.